here we go. Hungry. I'm going to make a machine. You're going to help me create it. This machine where if I push the A1 button, out comes a Snicker. And you know what? Snickers are so popular in this vending machine. If I pushed another, I'm going to have to put this up here where it should have gone. If I push the other A1 button, out pops a Snickers. So this is a really nice machine, right? You've got two A1 buttons, even though you can't see it right now. They all look like just A's. If I push an A2 button on this machine, out pops, these look like M&Ms. So that's great. So that means that if I pushed another A2 button on the machine, then M&M should also be coming out, right? So far this is a really nice functioning machine, a vending machine. If I push A3, Twizzlers come out. This is awesome. So far, this table represents a function where you know that if you push a certain input, you're going to get a certain output no matter how many times you push that input. So if we pushed an A3 and we got a Twizzler, this next time we push a different A3 button, oh my gosh, look what we're getting. We're getting carrots. Now all of a sudden this table doesn't represent a function anymore. I'm sorry that the ones, let's see, this is really A1 button, A1, A2, A2, A3, A3. We would be really upset if we pushed the A3 button expecting Twizzlers and out came carrots. So this is another way to think about something that represents something that's not a function. We have to, every time we push A3, we have to get Twizzlers out. If we push A3 again and something different comes out, it says the whole machine's not functioning. This table doesn't represent a function. And we could do the same thing here. What about if I pushed A1? Where did my A1 go? It's gone. And there's water. I'm not going to use the table then. How about I push another A1, water. I push an A2, water. A2, water. A3. This is just like example number 2, where no matter what number we put in there, out came a 5. So same thing with this vending machine. Have you ever been to a water vending machine, right? No matter what button you push, there we go, we can get them now. No matter what button you push, out comes water. And that's okay, that's a functioning water vending machine. It's all good. Okay, so my water just disappeared, but you get the point. Okay, so on the test, in your homework, you're going to be asked to identify whether a table is a function, it represents a function or not. So we're looking at a table. It represents part of the pattern of something that's either a function or not. And so I look at number 1 and I see, well, this is interesting. I put in a 2, I get out a 1. And they just keep telling me this over and over again as if I had forgotten. But this is, we're looking at this for a reason. It's okay to have all of your inputs be the same, only as long as all of your outputs are also the same. So this is a function. Yay! Let's look over here to see why this isn't a function. If all my inputs are the same, but all my outputs are different, then that's not going to work, right? Think about a vending machine. If I push a 1 and out comes a 2, that means every time I push a 1, a 2 better come out. But no, it's random. I push a 1 and out comes a 3. I push a 1, out comes a 4. This table is not functioning. It is not a function. Let's look at this. We're going through this. I push a 1, I get out a 1, push a 2, get out a 2, I push a 5, get out a 3. It seems great until, oh no, I push a 1 again, but instead of out popping a 1, out pops a 4. That's not functioning. In this table, when the input is 1, the output has to be 1. Because this messed up right here, then this table does not represent a function. So let's look at this. This is showing you again that, well, this table, it only makes 2, right? No matter what your input is, your output is 2, and that's okay. It's just a table that makes 2. Okay, so we're going to look at this. It says determine if the relationship below is or is not a function. So what I'm looking for here is do any of the inputs repeat themselves? So I'm looking at, oh, I see a -11 and I see a -11. So I have to be careful that both -11s go to the same number. When the input's -11 and the output is 20, when I see -11 again, that output better be 20 again within the same table. Obviously, if I'm looking at a different table, if the input's -11, the output's probably going to be different. But within the same table, they have to be different. Because this is not different, or this is different, it is not a function. So there's a rule that we can use to tell whether something's a function or not. And the rule is for every x, there is only one y. Another way to say it, for every input, there's only one and only one output that's going to match up with it. Output, there you go. It's hard to write and talk at the same time. All right, so let's look at 7. Sometimes data can be displayed in a different type of table called a mapping, like the one shown below. Can you tell if this table represents a function? So we're looking for the same thing. We're looking to make sure that for every input, or for every x, there's one and only one y. So let's see. 1 matches up with 3. Okay, that's good. 2 matches up with 8. That's looking good. 3 matches up with 2. So far, so good. 4 matches up with 4. And 5 matches up with 0. This is kind of easier because all of our inputs are different. And so that's kind of a little hint that we are going to have a function. We have to be very careful if any of our inputs are different from each other. All right, so yes, this is a function. Yes. Okay, function or not. So let's see. 1 matches up with 3. Uh-oh. 2 matches up with 8. And 2 matches up with 2. We can stop right there. That's like saying you could go up to a vending machine and push a 2, and one time an 8's going to come out, and the next time you go up and push a 2, the next time a 2 is going to come out. That's not a reliable machine. That machine's not functioning. So this is not a function. It breaks the rule. If your input is 2, my 2 as an input can only match up with one output, and this is saying it matches up with 2 different outputs. It is not a function. All right, create a table of values that is a function. So I don't know why we have 3 tables here. You can have fun. I'm going to create one table, and you guys can create however many you want. I could put 1, 2, 3, 4, 5. I could have fun saying, I'm going to make my table represent a pattern where every number is tripled. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. This is going to represent a table that is a function. I could also do something random. 1, 2, 3, 4. I could do 7, 9, 14, 21. That represents a function. And I could do a function that just spits out the same output no matter what. That is also a table that represents a function. So draw a mapping that is not a function. I could do this a couple different ways. I could do it like the problem before. 5, 4, 2, 1. I could make 1 go to 5. I could make 2 go to 4. And then all of a sudden I can make 3 go to both 2 and 4. And then that is what breaks it right here. That input of 3 can only match up with one output. So that would be a mapping that's not a function. Okay, function or not. Now we're looking at graphs. We just talked about how to make sure that tables represent a function or not, and how to tell whether they do. Now we're going to look at graphs. So if you think about it, we're still going to use the same rule. For every x, there can only be one y. For every input, there can only be one output. So when I look at this, I'm saying, I'm looking at this point. That's saying when x is 0, y is 6. That's great. When x is 2, y is 2. When x is 3, y is 6. So far I'm seeing that for every x, there's only one dot that matches up for the y value. And this is a function. Another way to look at it is to do the vertical line test. You can take the vertical line and you can drag it, and as long as it only hits one dot at a time, beep, 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 then it's a function. That's a second way to do it. So let's look at the following one that hopefully it's not a function so we can see the difference. So when I'm looking at this, I notice something right away. When x is equal to 1, y is equal to 2 and 5. Oh no, that's not okay. If you're going to be a function, your x can only match up with one y. When I'm looking at this dot, when x is 3, y is 4, there's no more y's that it matches up with. When x is negative 2, y is 6. When x is negative 3, y is 3. And yes, we can use our vertical line test as a backup, and we can see that as we go along. Beep, beep. Oh, look, I forgot this dot up here. There's two places that it messes with the rule. When x is negative 2, y is 10, and y is 6. So we're going to have a problem right away. Beep, beep, beep. Whoops. Beep, beep, beep. Okay. If it beeps twice, hopefully your line does beep as well, then we know that it is not a function. All right, function or not, we're going to do the same thing. We're looking for when x has more than one y that matches with it. So this is saying when x is 2, y can be 0. When x is 2, y can be 8. That's not okay. You got to pick one y. If I put this in a table, I'm sorry, you got to pick one x. If I put this in a table, it says when x is 2, y can either be 0 or y can be 8. That's not a function. And so it also breaks the rule here when x is 1. Does it break it anywhere else? And of course, you can beep along with your vertical line test, and you can tell that this is not a function. Okay, sometimes for 12 and 13, we were looking at scatter plots, and so for 14, we're just looking at a curve that's happened to be called a parabola. And as we do the vertical line test, we can see that beep, beep, beep. We're just going through and we're hitting one dot at a time. It's all good. It is a function. This next one, we're doing the same thing. We're going through, we're beeping, one time each. We're good to go. This is a function. And this last one, we can already tell we're going to have trouble, right? I mean, look, when x is equal to 2, y has a value up here and a value down here. And if we do our vertical line test, we're going to be beeping like crazy, right? We have one beep there, beep, but then everywhere else, beep, 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 beep. And that, my dear Algebra 1 students, is not a function. So welcome to the intro of function or not. We're going to build on this concept and have fun this unit. Thanks for joining me.